This is section 10.4, match pairs test. Problem number 1 here states a study was conducted to investigate the effectiveness of hypnotism in reducing pain. The results from randomly selected subjects are shown in the table. Here we have subjects A, B, C, D, E, F, G, and H with their before and after applying hypnotism. A lower score indicates less pain. The quote before value is matched to an quote after value. Assume that the population of differences has a normal distribution using a 5% level. Is there evidence that the sensory measurements are lower on average after hypnotism? So to start off with this, a little different. This is the first of our kind that we're going to do a multivariate, but it won't be that bad at all. So what we want to do, maybe just to start off with this before I do an introduction, all these, despite here the fact that I want to do a lower, this will later indicate for a left tail test. What we want to do is more specifically for all these, take the after number, after, in this case after the hypnosis, and subtract the before. This will eventually become our data. So we want to do that for the first subject. And we notice there for subject A, the after was actually more pain than the before. So when you take the after minus before, in this case, we'll get positive 0.2. However, for subject B, if we go ahead and subtract 2.4 minus 6.5, we get negative 4.1. I've already gone and done the calculation for these, but it'd probably be best if you grab a calculator and do these along with me so that you get used to that pattern of after minus before. Here, the next one here, 7.4 minus 9.0 is negative 1.6. Again, grab a calculator, verify that. Next one, take 8.5 minus 10.3. You're going to get negative 1.8. For subject E, we'll take the 8.1 minus 11.3, and that will be negative 3.2. For person F, 6.1 minus 8.1 is negative 2, or negative 2.0. For person G, 3.4 minus 6.3, negative 2.9. And then for the last person, person number 8 there, 2 minus, or 2.0 minus 11.6 is negative 9.6. So you notice that a lot of these have negative values. We want that. We want all those differences to be negative. That will help us show a lowering of pain. So in all these, you want to always take the after minus before. More specifically here, the after is the experiment group. So after experiment, and if you think about that, that's after they got the treatment. Those numbers reflect after the treatment there. That's the experiment group. And as if the experiment never happened, we can easily look at our before case as the control group. So this will set us up that we know that for the control group, this identifies with population number 2, and the experiment group is population number 1. So when I come down here and look at population number 1, I want to describe the after. And it's quite simple here, but let's go back and look at more specifically. We know that we're collecting a score that talks about the level of pain. That's what each one of those numbers describe, is the level of pain at one point in time from a particular individual. So here we have the set of all, the set of all pain scores after hypnotism. More specifically, you could say hypnosis. Now, as we said, that the before is population number 2, the control group. So all we really need to do here is copy and paste and change the word after to before, as if indicating this never happened. Before hypnosis. So those are our two populations for the experiment and control group. Now down here, we know that there is a population mean that's expressed for population number 1 and population number 2. We don't know what those numbers are, but for the null hypothesis, we want to assume that they're both equal, just like we did in all of chapter 9. But I want you to see that population number 1, again, is our after group. And then population number 2 is the before. So in this case, I can then say that mu1 is, quote, after, or maybe a subscript of A, is equal that of subscript of B before. If they're both equal to one another, just to help you better see that, we're really saying from the null hypothesis that hypnotism does not work. But what I want to do, again, is subtract those two numbers. Like I did before, I want to take the after minus before. Or in this case, I want to take the mean of the after and subtract the mean from the before. And if by assumption they're both equal, then their difference will be 0. And we'll end up using that later. So more specifically, we don't have to put in that much detail. All that we need for the null hypothesis is just to assume that both of those are the same, but yet we know that their differences will be 0. However, for the research hypothesis, we want that mu sub 1 for that first group to be less than that for the second group, for the before. That will show that the after is less than that, showing a decrease or a lowering in pain. Now that we have our hypotheses set up, we can look at part 2 here, verify the requirements, and then select our sampling distribution. So here in this case, this is going to go along the central limit theorem anytime we're talking about mu. N needs to be greater or equal to 30, or x is normal. So for this case, let's go ahead and look at the sample size. Let's go back up to the chart here, and we notice we have subjects A through H. You count all these, we'll know that we have 8 values, or 8 subjects. So therefore, our sample size is equal to 8. That doesn't make the requirement here, so the answer is no. However, for the next part is x normal, more specifically, is the difference here for x. So x is going to represent something a little different, the after minus before those differences. So is the differences normally distributed? Let's go back and look at that in the prompt. So here's saying that before is matched with that and after, and then it says assume that the population differences has a normal distribution. So using that assumption, we'll now verify that we have a yes for the differences. Therefore, that will imply that we can use the student t distribution, or for short there, t distribution. Any time that we use or describe the mean is always going to pair up with the t-distribution. So now that that's set, we can go ahead and draw out a generic t-distribution in the next part and find the cutoff score for significance. So let's go ahead and do that. We'll go and mark this between -3 to +3. Putting 0 in the center, -1, -2, -3. Over to the right, +1, +2, +3. Significance there at the top, on the prompt it will say that we have a 5% level, and that's equal to 0.05. In decimal format, we want to show lower, but more specifically, again, what we did back in chapter 9, because this is an arrow here, in this case for lower, pointing to the left, we want to perform a left tail test. So we'll go ahead and do that. Here we know that we have a left tail test. And that the degrees of freedom is equal to the sample size -1. Here we have the 8 subjects. 8 minus 1 will end up being 7. So we can combine the 0.05 left tail, the left bracket, with the 7 to find that cutoff score for significance. So let's go back over to GeoGebra to help us do that. So there's our student t-distribution along with 7. Already preset here for the left bracket. Now in the bottom right box, you want to place in the 0.05. There in the middle is our cutoff point, -1.8946. Again, -1.8946. So placing that back in here, that's the cutoff point. We want to be on that point to show statistical significance. And that's equal to T0. So anything in that left direction will represent the 5%. If we can be beyond that cutoff point, we can show significance here. In this case, we're assuming that the 2 means population number 1 is equal to the population number 2, the before and after group. To be as far away enough from 0, being past the cutoff point will help us prove that we can reject the null hypothesis. So let's go ahead and collect the sample for step 4. Here in this case, we know that N is equal to 8 because we have the 8 volunteers. X bar is going to reflect there for the differences and also the sample standard deviation. So our data, we're going to end up putting that in, is going to be only strictly the differences and no other value. You want those differences to place that into a calculator or some sort of statistical calculator gives us mean, and standard deviation. In this case, I'm using calculator.net. So what I've done is already place those values back into here. And we can see at this point here, the count is 8, the sum is -25. We don't need that, but for the mean or the average, -3.125, again, -3.125, we need the mean. And then down there towards the bottom, we want the sample standard deviation. And that one will end up rounding to 4 places because we're given data. So 2.9114 and 2.9114 for the sample standard deviation. I'll go ahead and record those numbers back down from using that calculator. So jumping back over here, we know that the differences is the average of those differences, -3.125. That's good. That being a negative will help us prove that decrease. The standard deviation is always positive 2.9114. We want to go ahead and standardize the sample mean. and turn that into a t-value. So jumping back over here, that t is equal to, by definition, we want to take the differences, the average of those differences minus 0, I'll explain that in a moment, divided by the sample standard deviation of the differences divided by the square root of n. In this case, the square root of the sample size. So plugging all those elements in there, we have already taken here the negative 3.125. You always want to start off with that statistic first, and then minus the claim. But the claim is 0 because from the null hypothesis, we're assuming, again here, both of those are the same. So we're going to go along, if they're both the same by assumption, then their difference is 0. And that's why down here, that this will always be 0. So think about that. Again, that's always 0. Because the null hypothesis will always assume that they're both the same. Then down there at the bottom, we're going to end up taking the sample standard deviation and then dividing that by n, which again was the 8, and plugging those elements in there. So we've got all the 3 different elements there from our data from calculator.net. Now all I need to do is grab a calculator and do that and figure out, round it to the 4 decimal places. So let's go ahead and grab a calculator and do a little math here. And plugging those values in. We'll start off with parentheses. For the numerator, obviously you don't have to because you're subtracting 0 from that. But here in this case, we've got negative 3.125 minus 0, close parentheses. Now what we want to do is divide that by, open up another parentheses. The standard deviation 2.9114 divided by the square root of 8. Close parentheses and then equals. And we end up getting the standardized value, that negative 3.0359 is our standardized value. So again, negative 3.0359. That's the standardized value from the sample. Is this number in the rejection region? Anything past that cutoff point, they're just a little bit past the negative 3. So here we're in the rejection region, and then I want to shade to the left of that for the p-value essentially later, that we can prove that there's a rejection of the null hypothesis. So down here, we're going to end up rejecting that assumption. Since the null hypothesis assumes that they're both equal, if I'm rejecting it, therefore I'm able to show that hypnosis does work. Let's go ahead and find the p-value from the answer we've got in step 5. I want to use the t-distribution to do that, so probably that t is less than negative 3.0359. This is a less than value, again, because I want to iterate that I'm doing a left tail test. This would be a little bit different if we end up doing a two-tail case. We'll go over that in another problem. So here what I'm going to end up doing is putting the negative 3.0359 back into GeoGebra. Let's go ahead and put that in that middle box there at the bottom. Again, negative 3.0359. Click in the bottom right box. That ends up turning to 0.0095. 0.0095, just a little bit below 1%. So 0.95%, just under there at 1%, that's definitely less than the level of significance. We can say that we can reject the null hypothesis that verifies that. In both cases there, they both imply the same thing. Therefore, we were able to prove that from the sample of 8 subjects that hypnotism does work in reducing pain. Before I want to conclude this problem, I just want to say that these are made up problems here, and don't take these for literal value. These are just examples to help illustrate. So don't be led under the assumption that hypnotism does reduce pain. These are just made up numbers to help you learn the math for these exercises. But this will conclude it here for section 10.4, match pairs test for example number 1.